Hello everyone, welcome to lecture series on analog circuits.
Hello everyone, in today's video I'll be discussing about the expression for voltage gain in small signal analysis. So I'll be starting with the diagram. That is, initially I'll be drawing one resistance here. This resistance is RC. The current flowing through this resistor is both AC and DC. That's why I'll write I subscript capital C, and then I'll draw transistor with emitter grounded, correct. And here are the input side. I'll be applying the input signal, that is both AC source, that is plus or minus V small b, and capital VB, that is DC source, V capital V and capital B. This is the plus or minus emitter base emitter voltage VB. The current flowing at the input side is I small I subscript capital B, that is the instantaneous value of the base current. This is transistor Q. This node is where I am taking the output, and here I am reverse biasing the collector base junction. This is collector, this is base, this is emitter. I am reverse biasing the collector base junction by applying voltage VCC higher compared to this base voltage, and I am taking the output voltage at VC. This will be my output voltage V small v subscript capital C. Fine. So if at all I want to derive the expression for voltage gain, then the notation will be AV. What will be the AV equation? AV equation will be equal to small VC divided by small VBE. This will be the expression of voltage gain. So in order to obtain the expression of voltage gain, what I'll do is I'll try to apply KVL at output side and to get the equation, some equation in terms of VC, right? If I apply KVL at output side, what will I get? Minus VCC plus IC RC plus VC equal to 0, correct? So applying KVL at output side, what I'll be able to get? Minus capital VCC plus I subscript capital C into RC plus small v subscript capital C equal to 0. What do I need? I need to find expression for VC. So what will I get? VC equal to small v subscript capital C. Small v subscript capital C is equal to what? It will be equal to capital VCC minus IC into RC. This is I subscript capital C, correct? But as you all know, IC is a function of IC is instantaneous current, which is comprising of both AC and DC current. That's why I write the equation as VCC minus small IC plus capital IC into RC. If I do so, now I'll try to separate the AC terms and DC terms. What are the DC terms here? VCC, this capital IC and RC, correct? So what will I do? I'll write DC terms one side, VCC minus this capital IC into RC will be one term, IC into RC. What am I left with? Minus small IC into RC, right? So out of which this term is a DC term and this term will be my small signal term, correct? So how can I write this as? This is small v subscript capital C, that is instantaneous value of the collector current, is equal to, I can write this term, since this is a DC term, I will write this as capital VC minus small v subscript small c. This is the AC term, this is small v subscript small c, this is DC term, and this is small signal term. This is, looking at this, it will be VC plus VC, right? So generally VC is instantaneous value of collector current is DC value of collector current plus AC value of the collector current. What is the AC value of the collector current here? I'll try to find. So comparing, I'll call this to be equation number 1, this to be equation number 2. So comparing 1 and 2, what can I write? Small v subscript small c. Small v subscript small c is what? Minus IC into RC. Minus IC into RC. What is IC? IC is nothing but GM into VB, small v subscripts B, correct? This equation I had already derived in the last session. So into RC, it is minus GM into VB into RC. This is small v subscript small c, correct? What do I need? I need expression of VC by VBE, correct? So what will I get? VC by VB is equal to, so I'll directly express this equation as AV is equal to what is the AV? VC by small VB is equal to, what will I get the expression as? Minus GM into RC. So this is the expression for voltage gain. But what do I know? Voltage gain, GM is, what is GM? So GM is IC divided by VT, right? This equation I already did. So it is capital IC divided by VT, that is the thermal voltage, into RC. So here we can see that AV is directly proportional to GM, and this GM is directly proportional to IC, correct? So AV is directly proportional to instantaneous value of the collector current. So if I maintain this collector current constant, then the gain of my circuit will remain constant. That's a very important thing. So gain directly depends on the output collector current. Fine. So this is one inference which you are supposed to think of for stability analysis. So here we can see that the same derivation I have done here. This is applying KCL to the output side. I get the equation of VC as VC minus IC into RC, out of which capital VC is the DC bias voltage at collector, and I'll get the expression of AV as minus GM into RC. Since GM is directly proportional to IC and AV is directly proportional to GM, we can say that by maintaining IC constant, the gain can be made stable, right? So this is the derivation of voltage gain. Once we are done with the derivation of voltage gain, I'll straight away get into one problem, a numerical. Here we can see this for circuit shown below, figure A. Figure A means this circuit. This is the circuit. So VB is adjusted to yield a DC collector current of 1 milliampere. What is the DC value collector current he is giving me? Capital IC is 1 milliampere. VCC is what? 15 volt. RC is what? 10 kilo. And beta is 100. He is asking me to find AV. What is AV? As you all know, AV, I have right now I have derived AV. IC divided by VT into RC. Do I know IC? Yes. Do I know VT? Yes. Do I know RC? Yes. So what will I get AV directly as? It is minus 400. There is no unit for voltage gain because it is voltage by voltage. I am writing it by V by V. Even if you don't write this, it is fine. Next, he is asking me to find if VB is small VB, that is the input AC signal applied is 0.005 sine omega t. Find VC of t, V subscript capital C of t, instantaneous value of collector current and instantaneous value of the base current. Since input signal is a function of sine wave, output signal will be a function of sine wave, and input current will also be a function of sine wave. So I'll try to understand what I'm supposed to find. How is, see, VBE is what? 0.05 sine omega t. So what is this value? This is the maximum value of 0.005 is what? It is maximum value of small VB. VM in general it will be VM sine omega t. VM sine omega t. What is the maximum value of the base emitter or input AC signal voltage? It is V subscript small b is 0.05 volt. Fine. So what is that I'm supposed to find? Small v subscript capital C into t. What is small v subscript capital C? It is instantaneous value of the collector current, which is nothing but VCC plus VC. I'll try to write the equation once again. So I have to find VC of t, which is nothing but capital VC plus small VC. Fine. Small VC sine omega t. What is capital VC? I have already derived here. Capital VC is what? VCC minus IC RC minus IC into RC. Correct. So I have to first find VC. What is VC? VCC minus IC into RC. Is VCC given? Yes. VCC is given. Is IC given? Capital IC given? Yes. RC is given? Yes. So I can find VC directly. What is small IC? Small IC is what? Small IC is GM into VBE. What is GM? GM is nothing but, I can write GM as IC divided by VT into small VBE. What is IC? IC is instantaneous value of the DC value of the collector current. What is the DC value of the collector current? 1 milliampere. What is the thermal voltage? As I said in the previous session only, it is 25 millivolt at room temperature. So I know this. What is VBE? VBE is given as 0.05 volt. So if I do this, I'll get the value of small VC also. Correct. Hopefully you are understanding. if I get IC value, what is VC? IC into RC. What is IC? IC is GM into VB. What is GM? IC divided by VT into VB. What is IC? I have, it is given. What is VT? It is given. What is VB? It is 0.005 volt. So that IC into RC will give me VC. So coming back to this problem which I have already solved. Here, look here. VC of t is VC minus IC into RC sine omega t. So what is VCC minus IC into RC? It is 5 volt. Small IC is what? GM into VB. What is GM? IC divided by VT into VB. So what will I get? 1 milliampere divided by 25 millivolt into 0.05 volt, that will be equal to 0.0002 ampere. So substituting, I'll get this 0.0002. I'll be multiplying it by 10 kilo ohm resistance because this is the IC into RC, correct? That will be 10 kilo ohm into 0.0002 sine omega t. That will be equal to 5 minus 2 sine omega t. What will be IB is equal to capital IB plus small IB. So what is capital IB? Capital IB is IC divided by beta. Capital IC divided by beta plus what is small IB? Small IB, as you all know, I had to write the expression here. Small IB is GM divided by beta into VB. What is GM? IC divided by VT. So it will be IC divided by beta into VT into small VB. That's the formula I am using here. 1 divided by IC divided by beta into VT into VB. So if I use it, what will I get? IC divided by beta plus GM divided by beta into 0.005 sine omega t, but because VB is sine omega t. The GM I already know, as it is IC divided by VT. Solving this, I'll be able to get the expression as 10 plus 2 sine omega t.